And we are live, episode 4, season 2, brand new board, Beagle Y AI. So, congratulations, new release, new board. Look at that. Robert's got it up. Mine's tied up in projects behind me. So
Ditto.
today we have special guest Jared, who's helped bring it up from TI. Done a lot of work on
Yeah,
it.
it's a pleasure to be here.
Welcome, Jared. All right. Well, exciting new board, exciting new launch. Jason, how do you feel about it?
Awesome. Yeah, no, this has been cool. I think it's just it's nice how easily you can kind of shove it into things, like just take existing projects and beagleize them.
Honestly, I think that's been the big difference for me too. I wasn't expecting that much of a usability difference, even over something like
Mm-hmm.
Play. And not to say Play is not a great board; it's got its own set of merits. But it's just been interesting that just the form factor and the 40 pin header, right, just lets you just shove it into so many things. And yeah, it turns out a lot of the stuff that is made for certain other boards is just kind of I2C in the background and kind of hacked together anyway. So it's you put it on Beagle Y and it just works out of the box, or maybe tiny changes, and there you go.
Yeah, I
What's
can't
that?
really show my little robot arm here, right? I was able just to swap out one board and put in a BeagleY AI in that and get a full AI robot arm. So
we have one that we have in the office as well, and we've been affectionately referring to it as Jason's arm. And people kind of give me weird looks, and I'll be like, no, Jason's robotic arm. He takes it off and gave it to us. But yeah, you guys did a lot of work, with Seed as well, on making sure that the board form factor is very, plug and play with certain existing ecosystems. I don't know if you want to name drop or not. But yeah, the pinout works out in a way that expansion hats work great. So we've already tested a number of them. Third-party PoE, for example, works from Waveshare. I've played with some motor drivers that just work out of the box pretty much. It's nice. You can just go on Amazon and grab existing accessories, slap it on Beagle Y, and it just runs with it. And as an interesting side note, I found that at least HDMI displays tend to be more stable on this board than certain others, especially when you have weird form factors. I have some extra widescreen ones with touchscreens that need a lot of changes on certain other SBCs, and on Beagle Y, just plug and play. You calibrate your touchscreen to it, and you're off and running.
I was surprised when looking at kind of the landscape of people building compatible hardware, open or not, how little of them actually were mechanically compatible, and how much more BeagleY AI was mechanically compatible than other ones. I don't know if you've had that sort of same experience with the prototypes. The only we do have that OLDI connector on the bottom, so a little bit of the bottom clearance stuff is just slightly different. I think we might even try to adjust some of the large capacitors on the bottom. I think we still have some time to try to shift to those, but we'll see how that goes. But that's been easily fixed with the Dremel. So I've just been really pleased with how nice of a job the Seed guys and us working with them have done at making it mechanically compatible, such that you can use enclosures. And where's the one I have sitting in my enclosure box? I don't know.
Oh, look, we have Meyer Makes in chat. Nice surprise there. Welcome.
Hey.
14 presents. Nice.
Hey,
Hopefully we'll get an episode from you soon. Get a board out to him.
Yeah, so that's I don't know. I've been super pleased with how much of the different mechanical accessories just work, right? There's just I haven't found much that caused me any problems, and that's not been the same with other third-party hardware that I've seen, right? Other keep not saying the word. It's too hard.
Yeah. All right. I'm gonna say
Gotta
it.
come
I'm
up
gonna
with
say it.
well,
Whatever everyone. This is an Andre statement, not a Ti statement, not a Beagle statement. It's Pi
you
compatible.
gotta
It's Pi enabled. It's fine. It's a Pi. It's fine. It's not a Pi. It's Beagle Y. Uh,
just you gotta come up with a code word like California fruit or something like that, you know? So it's
Like a Beagle Y.
yeah.
So, by the way, Y is so we should give it. So why Beagle Y? Well, it rhymes with
Sky.
and what it rhymes with sky, and well, so Y is actually like Beagle 5, right? It's a classical Roman numeral. Right? Y isn't a common one you've heard of. It's a little older than all the other Roman numerals. It's not that common. Doesn't kind of stand in modern Roman numerals, but it is a rational number. As opposed to other irrational numbers. But it is 150. Don't know if you knew that.
No, no.
Much like the ratio of AI performance.
Aha.
And one of the fun things with Pinmux that we're trying to do is using the Alea system and other types of overlays. The goal is same IO. So we're doing a lot of fun stuff with the Pinmux.
Yeah.
I got a message from Thomas Petazzoni this morning. There's a new discussion on the device tree list to try to build device tree connectors, right? So that's very relevant here.
Because I was thinking about that too, because the connector is a nice subsystem to move I/O from different regions and remap them. So this would be a fun one to play with that on. So
yeah, with the Bootland guys, we've already done a lot of the legwork, right? And even initially, because we did it to try to make the BeagleBone Cape headers compatible no matter what the SoC is, right? So moving to new generations of SoCs that you can still have a single device tree overlay that would be supported across all the different SoCs that might have compatible Cape headers. So the same thing, like it was already thought through to and pushed upstream into U-Boot, right? The things that are necessary for doing it with hats. So we've been working on the infrastructure for this, in the open source development community for a while. And, this really gives a good point, to try to there's a lot of opportunity really just to make everything just work, right? Across whoever provides the baseboard. Right?
Yeah, so I suspect this is going to end up just benefiting the community, right? In general, it's not just Beagle here that's going to benefit from it. Because I think hat adoption, like you said, mechanically it's there, but a lot of what's been tried so far, the EPROMs and reading IDs and auto configuring, just kind of hasn't materialized, just because nobody's really been interested to do it. And that's kind of a classic challenge, right, with any kind of modular ecosystem. But this should be a good push for it.
No, I think rising tides raise all ships, right? I think this is actually very beneficial to everybody, right? I mean, I think this is imitation is the sincerest form of flattery, right? I think that we I appreciate very much what those guys have done, and I think that but providing an open hardware platform in that ecosystem, I think just helps everybody out.
And one of the nice things, it's still very early for this. I mean, the J722S that's on here was just RFC'd for U-Boot this morning, so we have a lot of time to tune things before.
Yep.
So whatever Chabas wants to do, we can do it right now.
Device, the official name for the industrial version that's on there is AM67A.
Yep.
But Yeah. And we were just talking about this right before we went live, but on docs.beagleboard.org there will be a full list of what hats have been tested, and if there's any changes needed, anything like that. We're gonna try to keep that up. One of the questions that we've seen on the Discord, and if you're not aware of the Discord, make sure you join the BeagleBoard Discord. There's going to be a link in the description. We have a lot of discussions about the boards there. Jason's on there, Robert's on there, Jared and I are also there. So if you ever have questions, that's the best place to do them aside from the forum. The forum is still very much active as well.
Yeah, we're starting to get a lot of questions on how to use all the R5s.
Exactly.
On this chip, the M4 for booting has been switched to an R5. So now we have multiple R5s to play with.
Yeah. And people ask, why is this PRU going away? I keep seeing that. And PRU is not going away. Like the official TI stance is that PRU is very much still in active development. We're working on it. It's just we find that on a lot of the what the market kind of demands, right? Is a lot of people are interested in something that can do real-time control, but they don't necessarily want to use a different ISA. They're used to ARM, they're used to R5s or M4s. So that's kind of a more general path for real-time control in all of chips. So if you're going to take up die area, a lot of people prefer R5s. PRUs is still going to be there, but they're going to be used more for stuff like ICSSG, where you actually want to also be able to use it for industrial Ethernet, things like that. And there it really gets to stretch its legs. There's still going to be general purpose chips, of course, that have PRU, but that's the official line for everyone that's asking, what's happening to PRUs. Not going away. That's why it's not on this device.
Yeah. Well, so we've got it in the 6.2 family, right? So the Pocket Beagle is going to have a ton of PRU pins on it, right? I think that was probably one of the biggest knocks on the Beagle Play is not enough PRU pins on it. And the plan is right to do both Pocket Beagle and BeagleBone form factors with the AM6.2. So certainly not moving away from that, right? So you'll see, Pocket Beagle and BeagleBone form factors continuing to carry PRUs, right? But in this Beagle Y form factor, right, the R5s or the R5s are the king here for the high speed IO, right? And I'm excited this has DSP and getting more about how to program the DSP on here. One of the questions, I don't know if you've read all like the Y Combinator stuff or any of the like stuff that shows up in like places like Reddit, but
oh yeah,
when people hear tops, they really have no idea. Like, okay, 4 tops. How much is 4 tops? What can you do?
What does it actually mean? That's always the question.
I mean, what I like to kind of it's a valid question, right? Like it's one of those where it's like it's kind of like gigahertz on CPUs. Like it really that moniker from like the early 2000s really doesn't work anymore. Like you can't compare 5 gigahertz on Intel versus 5 gigahertz on Zen 3 versus Zen 4 or whatever, right? But the closest I would say is imagine a Coral TPU. It's that kind of level performance, similar, right, for video inferencing at least.
How much did you say? Like
it's 4 tops, and I think a Coral is also 4 tops.
Yeah.
It works out about the same, right? So if you're gonna have an external Coral PCI accelerator, it'll be there. It'll actually be interesting because we could, with PCI
lose some
Express
bandwidth that way, though, right? I mean, Coral, I don't think you'll get some performance definitely out of going with the Beagle Y versus trying to do.
Yeah, and I think it's going to be interesting, right? Once we can try to mount a Coral on Beagle Y, and we can actually do head-to-head comparisons if we've ever wanted to.
Yeah, I mean, because so there was the original standalone Coral, but they did a Coral dev kit that actually combined it with an NXP processor.
They did, yeah, and that was over I don't know if that was over PCIe over USB 3 because they support both.
I thought it was PCIe with the TPU, but yeah, I think that was a fair bit. That would be a reasonable like comparison point, right? But this is a lot cheaper and a lot, I think, more readily available.
Exactly. I think this is the price of the TPU itself, basically, is what you're looking at.
Yeah,
and that leaves your GPU free, right, at that point, because there's also still the beefed up GPU on Beagle Y.
Yep, the 50
The 50
gigaflops, right?
Yeah, and I think that's one thing we actually haven't really mentioned in any of the promotional materials yet. What imagination GPU it is, because people were asking, what exactly the GPU was. I don't even think we said it was a 50 gigaflop GPU, right? Because it's much stronger than what's on play on AM62.
Yeah, but what does that do to the? I mean, ultimately, we've got to have good open source driver support if we're gonna have long-term HMI support, right, on this.
Yeah.
Like the AI64, right, has 8 tops, right? That's a little more than twice the price of this. Like a Jetson Orin Nano is like 40 tops. That's like $500.
Yeah.
Yeah. And when you're compared with the AI64, the other nice thing that this board brings, it has the Wave 5 encoder, and also the Imagination's JPEG encoder. So there's a lot more hardware blocks to actually do the video algorithms before you get to the tops. On the
What's
AI
the Wave 5?
It's Wave 5 was pushed to mainline, I think, 2 releases ago, but it's a CNC Wave 5. Yeah, it's basically a video decoder engine.
Oh, is that the VPU
Yep.
IP? Okay.
Yep. So a lot of things, like when you're comparing this to AI64, this chip has some more IP blocks to help speed it up.
Because we have VPU support on the AI64. You're saying it's
this chip actually has a discrete Wave 5 on it. So from chips
and that TDA4 VM does not.
Nope. I'm pretty sure on the TDA4 we have to use the. I'm pretty sure on the AI64 we have to use the M4 with a special firmware to do it. We're on the AM67. It's a discrete block.
That sounds right.
Yeah. Okay.
Right, yeah.
So we can get there from AI64, but we don't have the upstream support without having to load some firmware.
Yep, you lose the M4. Yep.
Okay. Well, I think losing an M4 on the AI64 is probably not that big a deal.
It's an easy trade-off, yeah.
Well, the nice thing is it's fully mainline, so there is a firmware on mainline, and so yeah, it works. Whereas the M4, you have to load the right firmware, and yeah.
Yeah, having the video codec support and V4L, so all the V4L stuff is going well for encoder decoder. You've already run those.
I have not, but I've been told they work.
That's the wonderful thing about the community, right? Is people just kind of run and do stuff, and each of the everyone has their own interest. I want to just jump to Jared really quick here, because Jared's been doing a lot of the bring up work, from the TI side, and he's been a gold star, just helping us with everything. I've been bothering him at work way too much. He's already busy doing other things, and I'm like, hey, gonna do this for BeagleY real quick. Like I had him help with I2C a couple days ago.
Especially with the last couple months of unreleased hardware, Jared's been like, okay, what's this magic bit do? Jared's been finding it, so.
Yeah, a lot of internal doc searching, which just irritates that it's like just push it public already. But
well, now the AM67A doc is public, so
yeah,
everything's public. I am no longer the one with all the magic bits and just gatekeeping it all.
Yeah, but, you're still the only one that knows what all of it means. So.
Yeah. That 2000 page TRM got it all locked away.
Hey, it's better that it's there than not, right? If you want to look through it, it's publicly available.
That's true.
So
it's nice. It's nice to have some
of the blessing and the curse.
Some of the docs. Yeah. Until you reach the IP blocks that are still NDA'd, but and you see the TRM, you have pages on pages for some parts, and then like a paragraph for some. You're like, something's up. But yeah, it's been a lot of device tree work, which has been, painful and not painful at the same time. Depends on who you ask. But yeah, so excited to still do just miscellaneous hats and things like that whenever I got the free time. Andre will probably ask me for some other stuff at some point. Say,
Yeah.
hey, can you bring up another overlay? Like,
Yeah.
man, I got work to do.
I'm throwing too many DSI displays at poor Jared, but DSI is one of those things that even the Pi hasn't. I don't think anyone's really figured out DSI properly. That's just my theory. Just because every display manufacturer seems to want to do their own thing. And DSI is just a bit of a
Yeah.
weird goose when it comes to the low speed to high speed communication and how Linux probes it. There's also, I guess, not the display manufacturers, but the Linux kernel guys don't want to just have generic DSI as the display type, right? So that all kind of complicates
Yeah.
things a little bit.
With the RPi DSI panels, there's a bridge on it that does all the DSI handshaking for you. It's like if you don't have one of those, that's not standard as well. So like you could get a WaveShare one that uses a different bridge, and then you're gonna have to do something else different, which is just massive pain. But yeah.
So you end up with like
Or as we found out, it changes from year to year on even the same model.
Yeah.
Oh yeah. When you have
all the timings worked on one, but not the next. Yeah.
Yes. I have no idea what's going on there, but yeah.
Reminds me, I got a DigiKey box with a bunch of cables. I get to go test some DSI here soon.
You got the official ones, right?
Yeah, that's what I got.
Yeah, these work great. So yeah. It's nice to use pre-made cables that just work.
Yeah.
You buy them off the shelf. Thank you for some other manufacturer for building them.
Yeah. Andre keeps buying random DSI panels. I'm like, test this one, Jared. Test this one.
I was given the TI credit card and told you are allowed to buy things to test things. So I've been using it very well.
Just swiping the Amex.
Yeah, because there's a lot of nice panels out there.
Actively testing things. Yeah, that's the problem with DSI is and displays in general, right? We get asked a lot, as Beagle as anyone else, right? It's why are displays so expensive when you can get, sub $100 HDMI ones? And the truth of the matter is that it's a volume thing, right? It's nobody wants to spin off a one-off display for DSI or LVDS or any interface that is an HDMI. And even when they do, they're a little expensive, like $200-300. And even then, they're usually basically an offshoot of a tablet. And that as long as that tablet exists, great. But the second the Lenovo tablet or whatever stops being manufactured in a year, then that display also goes EOL. And so that's kind of what it is. We found that working with display manufacturers is a challenge to put it simply.
I gotta go get a charger real fast. I will be back though.
No worries. You want to talk about OS compatibility, I guess, because that's another big one, right? As we're not just saying strictly Debian.
Yeah, I mean, I've been spending most of my time actually working with like customized images for other machines, and then just making them bootable for BeagleY AI, right? So starting out with not Robert's images for once. It's a strange new world.
Yeah, because we're booting up the micro SD card on these boards. As long as there's a FAT partition, we can pretty much boot anything. So, yep, we just got to basically copy the bootloader files over, set your X to Linux file, and just make sure you brought in your own kernel device tree and the Z image, or I'd say uncompressed I image, and it'll basically boot.
Yeah, I wish
otherwise
there was some way.
Otherwise, it's a standard ARM64. So,
in EXT Linux to detect which computer you were on, like to do something with the some type of like the board model number or something, anything.
Nope. X to Linux is just dumb. It's just whatever you write it is what it does. So it has to be before it.
Yeah. So I changed the default in order to swap my SD card. If I want to take my SD card and boot it on another board, I changed what the default is in the X to Linux to point to the one I want, and then and then it boots and runs.
Yeah, as long as you have a serial, you can actually just use Robert's little boot menu as well. So
You know I'm allergic to serial cables.
I know, but
But we do have the serial cable connector right on it.
Yeah. And the
Yeah.
little, the I guess I can definitely use it in this place, but the Pi debugger works great for that.
Yeah, the Pi debug header is great. Buy a Pi debugger. They work good. I wish they were USB-C. That's my one complaint, please.
Yeah, who's using micro
Yeah, Evan,
USB
if you listen to
anymore?
this, please.
Please type C already. Type C.
Yeah. Like I have a Pi 02W I got somewhere. It's also like bothering me that I have to get Type C micro USB cables for it.
They have a power detection thing that in that little debugger too that I don't know exactly how they did it. I mean, not necessarily that hard, but I'm kind of intrigued by it because it can I think it's safe to not drive. Like we have the protection circuit. I don't know if the other boards actually have the protection circuit in them. So like if you use our debug header with the powered up serial, you're not going to blow up the board, right?
It looks like they have buffers on
Is there a buffer
on both,
in on the other board?
Yeah.
But the debug header actually seems to be smart enough to to not drive anyway. I'm not sure if that's true or not, but it seems like it is.
I think so, yeah. It's it looks like it's just the RP2040 doing the most of the legwork, a 5-volt regulator, the Q-SPI for its memory, and then they just have those buffers there. They published the schematic for the debug probe. That's very nice of them.
Oh,
very simple
PDF.
schematic, yeah.
Yeah, that's the other thing. Full schematics.
Yeah, not PDF.
Yeah, not just the
PDF.
debug probe, the whole thing.
The whole thing. Well, actually, there are some limited PDFs on their boards, but PDF is a far cry from like actual source schematic and layout, right?
Yeah.
So, and I don't know. Maybe they'll decide to release that, and I'd actually be happy if they did.
I'm not speaking for Jason here. I'm speaking as me here, but open challenge to every SoC maker out there and every board maker. Release your schematics for the boards. Stop hiding it. People want to make stuff with it. I want to make stuff with it.
Well, it's just not the barrier, right? I mean, that's not. I mean, if people can't buy the chip, right? What does it matter if you give them the design?
Yeah,
I don't get it.
I argue the same thing. Same for displays, right? It's just give me the pinout. Give me the timings. Why secretive about it?
Yeah, I mean, there's other barriers for like making sure people come to you to buy boards or whatnot. Then spinning a board, I mean, it's expensive, but it's not so expensive. There's actually money to be made at it that you can't do it, right?
And the people that really want to do it, they'll do it anyway, right? It's more the hobbyists that we want to enable, right? Kind of small time, but yeah.
Which reminds us, we have the task of because this is yet again done in Allegro, of exporting and making available for people that want to get it into KiCad. That's the big one for me, is getting it into KiCad.
Yeah, you can put that on my list of things. I have the licenses, so I can do it. I did it.
The nice thing is KiCad has some had examples already yeah. I guess the only big difference is we followed the new PoE spec. So
yep, the PoE hat works.
Yep. So the PoE is down there versus on the top.
One cable power, and you're on the network with it. So if you want to play around making some IP cameras or things like that, you have the dual CSI ports. Plenty of power to drive them. And we actually have just as a quick side note, we've worked with ArduCam for the FPD link multi-camera solutions, right? So we have the quad board, so you can use a single CSI port, 4 dual CSI ports, and you can get 4 cameras out over multiple meters of coax. There's also a Raspberry Pi compatible hat that is 2 cameras. So that way you could do 3 cameras on this board in theory, and we're testing that out internally as well. But it's sub $100 to get 2 extra cameras. It's a fun solution for people that aren't aware of it.
Well, so I guess you're saying that like to try to do 8 though, right? Because you've got the 2.
You can do 8.
connector.
Yes, you can also do 8.
Is there enough bandwidth?
There's enough
DDR
bandwidth.
bandwidth?
You're gonna be yeah, you end up being a little limited, not necessarily by DDR bandwidth, but the CSI bandwidth itself. So I think you end up being at like you can do 1080p 30 FPS, I think is kind of where you're at for video streaming. But that's concurrent on 8 streams.
Okay.
We haven't tested that on 6.7 as far as I know. It's been tested on 6.8 and 6.9. But I think I think 4 to 6 is definitely doable. 8 might be, starting to push it on DDR bandwidth especially, but yeah.
There was some talk on the on X or Twitter, whatever you want to call it,
X from
about the ISP bandwidth, right? So I've seen somewhere 600 megapixels per second. What is our real ISP bandwidth here?
Jared, I think you're gonna have to comment on that because I don't remember for 6.7 off the top of my head. So one the kind of hack we do for Beagle Play normally, right, is we use that doesn't have an ISP at all. So you can use cameras that have an ISP themselves, and then you don't run into that bandwidth at all.
Yeah. I mean, there's an ISP tuning guide, right?
600 megapixels per second. Yeah.
Yeah, and there's an ISP tuning guide for this too, right? So we're not stuck with.
There is, and then you're not stuck with just IMX 219 or whatever's out of the gate. But
will we push the live camera? We always wonder.
Yes. Yes.
A live camera is happening. Is that a promise? Is it what? Andre.
I haven't been part of those talks, but considering how on 6.2 lib camera was very quickly taken by their devs and built, I think there's a very good chance on this guy that'll be, if not at at mass market availability soon after. I think that's a safe bet.
Yeah, because
we definitely want it. Like that. There's no question that we want it, right?
Because if you watch the live camera mailing list right now, there's a lot of software IPAs and software ISP solutions coming down the pipe. So, yeah, there's a good chance that we could use that for these products in the 6.2.
Yeah, just to kind of adjust people's expectations though with ISP tuning in general, right? Like there is a tuning guide, and every vendor provides their own tuning guide, but it's really not as easy as you bring your own camera, and Jared can speak to that. But it's not you bring your own camera and you run the little tuning algorithm and out goes your driver, right? It's a very involved process, and there's a reason why there's multiple companies that make their entire it's their raison d'etre for how they make money, right? It still is a bit of an art, but we are actively trying to on the TI side at least trying to enable more cameras for the processors out of the gate,
because there is so much ability to differentiate in the ISP code itself, not just the tuning, right? Because that's just so much more reason why to open it up. And I mean, lib camera is would be huge, a huge start to that. But there's these ISPs are actually very programmable, right? And they kind of have to be, because there's a lot of it's not just the demosaicing and the all the. It's been too many years since I've done this, but right, there's a lot of opportunity to differentiate in a lot of different algorithms, not just your 3A, 4A sort of stuff, right? There's a lot more stuff going on to compensate for the fact that the manufacturing process for these CMOS sensors and right is just not right. There's just a lot of cost to be saved,
Yeah.
and a lot of it that can be fixed in software. And that's why you have these cell phones, right, that can take these amazing quality pictures with really junk sensors, right? And so I think it'd be huge the more TI can open up programming of the ISP. So hopefully we'll see a lot more of that.
I see Jared looks like his connection's dropping in and out, but right now there is an ISP tuning guide that TI provides. Sprad 86 is the official document name. It's called the AM6XA ISP tuning guide.
86, you said?
Yes, if you look up AM6XA ISP tuning guide, there's a document there.
Okay. Espure D86, is that it?
Yes, I think so. And it's not the most comprehensive thing, frankly, but it's it's definitely a start. And there is a tuning tool we provide. And it's actively being worked on.
It's really not giving a full programming guide. This doesn't look like, right? It's really just a parametric.
Correct. There are other documents also that you can kind of reference. There's TDA4V mid VPAC ISP tuning overview. And it's kind of scattered right now. I can tell you internally there's active development on it, and we're trying to make it more readable. A lot of it is just same thing, I guess, as the DSP sometimes, where you're trying to condense down a lot of information to make it readable to somebody who's not familiar with the actual IP design, right? But yeah.
Well, yeah, it looks pretty active though, so it's
It is, yeah.
Yeah. So that's awesome.
And ArduCam's also trying to provide on their own side their version of their guides, right? So they've actually been doing a really good job of that too. They have a full V3 link camera solution kit quick start guide set up. That doesn't go into tuning, but they're providing their services as far as enabling new cameras.
Sure.
I'm excited because I want to see global shutter. That's my big thing that I really want to see. I think it's interesting because a lot of those are trickling down from automotive. So for those not familiar with global shutter, normally you're scanning the sensor top to bottom, right? So if you're moving really fast, you're gonna have these artifacts. You can actually probably see my hand kind of juggle back and forth. But with a global shutter camera, you're actually getting a full picture of the sensor every time. So you lose some dynamic range. There's some downsides to them, and they're more expensive normally. But what you gain is motion clarity, right? So if you're trying to do image recognition of something that's fast moving, for example, you're trying to count small things. A global shutter camera is kind of unbeatable there because all of a sudden you have a full image that you can send over to your accelerator. And yeah. I don't know. That's I get nerdy about cameras. Sorry.
But some of these high-speed cameras, right? I think looking at the super high-speed camera applications could be of a lot of interest, right? So I don't know how suitable this is for some of that. My son's into baseball. I'd love to be able to measure his spin rate, for example.
Yeah, I'm actually curious. Some of the cheaper global shutter cameras, like I think IMX296 is one of them. What is it? Yeah, IMX296. I wonder what the frame rate on that is, right? I think if you lower down the resolution, they'll go up to a couple hundred FPS if I remember right. On some of the sensors, but yeah, that would be interesting, right? It's just you can do because especially once you go to low resolution, right? You can inference a lot faster at that point too if you're trying to do anything like that.
Well, I think I have a challenge here. Then I will.
We're issuing a lot of challenges this episode. I think we're more so than usual.
Well, that's the thing with new hardware. It's like let's see what we can do.
Yeah, let's push it.
Is it really similar to AI64, right, in terms of the ISP capability? right? Because then we've got this essentially compatible, you know, they're not the same, right? They're the edge connectors instead of the vertical connectors, right? But we've still got the same 22 pin connections, right? So
pinouts the same. Like, electrically, you'll be fine. It's just yeah. Any small
it's the
software
software
differences.
I'm concerned about, but
I don't think the ISP should be that different from AI64.
all right. And that's it.
Don't hold me on that, but my theory is that it's not.
I'm going to see if I can capture baseball spin rate.
This is gonna be, we need to start doing shorts, and that's just one short is just Jason going, I'm gonna capture baseball spin rate.
I was thinking millimeter wave might be kind of one way to do it, right? Just try to see the echoes, but I don't know that it would be like, because there's going to be some sort of Doppler effect based on the spin rate, but I don't know if that's would be better.
Is this a 60 gigahertz radar that I have connected to BeagleY AI behind me? Could it be? No.
Yeah, I don't know if that's going to be better off than. I'm very interested to see what you're going to do there, but I don't know if it's better to do visual camera, because the hard part I think is focusing on the seams, right? How do I get the
well, and it depends on the range too, right? Because I think your point cloud ends up being not necessarily that detailed at a distance, so you might capture the ball. I'm not enough of a radar.
That's why I was really trying to think of that, because I would not expect the point cloud to be very detailed, but I was hoping, like, thinking about it in terms of the millimeter wave, right, is just the difference between like one edge of the ball and another edge of the ball. Is if I managed to get a couple samples, even not, I mean, I'm not going to hit the edges, but if I can get 2 samples on the ball and get a differential, my hope is if I get 2 samples on the ball, that the change in the Doppler reflection, right? Because I believe your point cloud data includes both the I mean, I believe that you get some of the not just the first derivative with the velocity, right? But I think you get some additional. I thought there might be essentially a second derivative to the in the data that you got, but I'm not sure.
I'm not sure. I just started playing with it. I do know somebody who would be very interested to talk to you about it, though. So remind me after the call, and I'll put you in contact with somebody from the radar team, because they're playing around with things like that too. There's a lot of just fun things you can do with these guys. It's surprising, but it'd be fun to try to integrate it with BeagleY. And I guess speaking of why I'm playing with this, we're all gonna be at Embedded World next week. Big show, Nuremberg, Germany.
Sweet.
Hopefully, we'll see some of the viewers as well.
As I come by, see it. There'll be AI's presence. So.
Yep. When I see Alex in chat, he was responding. Sorry, Alex, if I didn't see your chats, but yeah, 600 megapixels per second and 8 cameras might push DDR bandwidth. So do you want to talk, Jason, about what we're doing at Embedded World next year? Next week. Ooh,
next week.
Next week, yeah. I'm getting ready. I'm getting ready to fly out tomorrow. So.
Well, we have a obviously the robot arm, right? So you'll be able to see the robot arm doing some object recognition and some pick and place stuff, all driven by BeagleY AI. There will be a triple display going with BeagleY AI. Thank you.
Yeah.
Thank you,
Jared. Jared, you wanna talk about it a little bit, because that was your baby, and it's the first time you do it on a device, so that was just a challenge.
Yeah. The three display HMI demo built by KDev. Thank you, Kate, or created by KDev, built with Qt. There's specific jargon that needs to be said, but so factory automation, HMI demo, 3 displays, OLDI, DSI, and HDMI all running at the same time. So
Yep, and I
That'll
think
be
we're at
that's
1080p HDMI and then 1200p OLDI, so that's LVDS for those that don't know. And then what's the DSI? That's I think the PI display,
the
right? So 800 by 480. But
I think
I
it
mean,
was 800 by 480. Yeah.
yeah.
So
But that in theory could go
yep,
up
and
still. But
then
that's just
Yeah, it's
yeah,
capable of 2 or
and
4K or something like that.
I think that sounds
should be.
yeah.
Make you guess
Yeah.
which one of those it
But
is. I don't remember which one. But I think it's 4K. I'm not sure.
Yeah. No, yeah,
What I recalled is the OLDI and the DSI were both 4K capable, and then
yeah, not quite 4K. 38 for OLDI is 3840 by 1080, and then the DSI is also 3840 by 1080. So it's a ultra wide 1080p if you want to look at it that way, like super ultra wide. So
would that
if
also be
4K
2K?
4K would be, yeah, it's around 2K. So 4K would be 3840 by 2160, and this is 3840 by 1080. So
Okay.
yeah. And that's a pixel clock limitation, so it's 300 megahertz pixel clock for DSI.
Yeah, and I think in the HDMI we're limited by the
Yeah.
pixel clock on the PCB, right? So I don't know if it's the IT framer or
the IT framer is going to be limited to 1080p, 60 hertz.
But because we're coming across parallel, right? That's just parallel RGB, 24 bits per pixel.
Yeah.
Right. So at 1080p.
Yeah.
1080p 60, right? That's 60.
1080p 60, yeah, and that's actually the limitation of the IP block 2 for DPI for 24-bit. But that's also because once you go past that, right, you're already at a what is it, like 300 megahertz pixel clock. So over DPI especially, right, it's not a serial interface. You're starting to add a lot of noise to your PCB, so you really don't want to go much higher than 1080p for DPI. You want to go to a different interface like embedded display port or OLDI or something differential, right?
Yep.
Sorry, got to nerd out on displays too.
And so we'll see those demos. There's at least one more very exciting demo, Andre, that you got to work on last week that we can't yet announce.
That can be blurred. It's blurred behind me. I don't.
It's blurred. Keep it blurred.
Yeah, it's
Keep
gonna
it
stay blurred. It's gonna stay blurred. It's
Keep
gonna
it
stay
blurred.
blurred. Yeah.
But
there's tubes. We can see tubes. There's an HEB thing.
Very excited about that demo.
There's a bottle of vodka behind me that I don't know if you can see somewhere.
Yeah. Too much detail already.
How does it all add up?
Yeah, I'm very excited about that one. That is, if worth taking a trip to the TI booth on its own to go see that.
Absolutely, that one's going to be very visually fun. Yeah, it's been working on it for like a week and a half now. It's been a lot of fun. But again, that it's been part of the surprise of why I've found that working with existing hats and things like that has been just pretty much a no-brainer. Like that was the part that did not give me any trouble. I was expecting that to be kind of annoying, honestly, and it wasn't. So
yeah.
Yeah, and I say kind of annoying, right? Because
you got the I-squared C lines.
Yeah, when I say kind of annoying, right, it's you got to realize, right, a lot of the you're dealing with a brand new SoC that's just been brought up. You're dealing with a brand new board that's just gone through testing. A lot of the stuff is just it's so new that nobody's really tried to do it before. So it's in theory it should work, but it's has anyone tried it yet? No. So until someone's tried it, there's always the question of is there some weird bug somewhere? And with this board, I think it's been pretty painless. And that's nice. Also shout out to Seed for the power delivery, because I've gotten my Pi 5. I've been trying to play with, trying to get the same thing just running on both just for some comparisons. And the Pi 5 I've gotten to power crash several times. And this guy's been rock solid as far as, not browning out on a 5-volt 3-amp supply. So, and I've been loading the USB ports and the header. So good stuff.
All right, why don't we end this so I can get my shopping list for starting my high-speed camera project?
No worries. Yeah, exactly. Jason's got work to do. And also we'll be at EOSS the week after Embedded Worlds. We have 3 weeks of conferences actually where we're gonna have BeagleY around. We're gonna have Beagle.
The open
Yeah, and
source
the Open
hardware
Hardware
in
Summit.
Montreal.
Open Hardware Summit. Yep.
Yep. So Open Hardware Summit, Embedded Open Source Summit in Seattle, and Embedded Worlds will be all over the world. We'll be ready for people, as long as all over the world is the U.S., Canada, and Germany. We'll be in Asia and Africa soon, maybe. All right. Well, thanks everyone for watching. This has been the BeagleY AI episode. We're really excited, right, about what's coming up. Lots of documentation to work on in the meantime. Lots of little projects.
Yeah, I think that's why we lost Deepak. He had to go write some documentation.
Yeah, he's been coming up some great art in the background as well.
Yeah,
So working hard on making things pretty. So that's exciting. I think this is going to be a good launch.
He's been doing a lot of work, so very very much appreciate. Everybody in the team has. So thank you very very much for helping us get here.
All right, thanks everyone. See you soon, and see you in 2 weeks, I guess.